This conference will now be recorded.
Product for us, and excited for you to see what Jim has to show for the next 30 minutes. So go ahead, Joe. Jim.
Awesome. Thank you, John. Appreciate it. Yeah, so today what we're going to do is we're going to dig into SpaceClaim a little bit. And, you know, I myself come from a Creo background, pro engineer back in the day, pro engineer Wildfire Creo, and then years in SolidWorks. And a lot of people we talk to, a lot of our customers have a very similar sort of history, if you will. You know, I learned CAD in college, whether it was Inventor or Solid Edge or CATIA, whatever. SpaceClaim is a 3D CAD program that is in the Ansys suite. It's been in there for about 15 years, I believe. At one point in time, it was a standalone CAD tool and was out there on the front of the open market, if you will, competing with some of the CAD tools that we probably use on a daily basis. But now that it's in Ansys, Ansys has been doing quite a bit of work on making sure that it has not only the CAD modeling, sketching, and modifying capabilities that we all know and love in CAD tools, but additional tools specifically for if you're going to be preparing for analysis or if you're going to be working with, for example, scan data like STL files. And so what I did for this demo, which is a little bit longer than 25 minutes, to be honest, it's a kind of a lie there, it's closer to 35, is I've got 5 sort of key capabilities that are in SpaceClaim that I think, are probably not well known by those of us who spend most of our time in another CAD tool like Creo or SolidWorks, but are very, very, very powerful, including the latest capabilities that came out just 2 months ago. And for those who have heard of SpaceClaim, for those who have it but don't use it, if you've got an older, I'll say an older, quote unquote, older workflow or a different workflow where you're spending time pre-processing in your CAD tool or in Design Modeler or some other tool, hopefully what today does is spark some interest and curiosity in what SpaceClaim has to offer. And so we're going to be talking about the different workflows, whether it's direct modeling versus sketch-based modeling. We're going to be talking a little bit about FEA and CFD preparation, but next week, Terry, one of our other application engineers, is going to be digging into that particular topic in much greater detail. Today, I'm going to be going through sort of a higher level, general sort of CAD capabilities, faceted models like STL files, and things like that. And then at the end, we'll have some Q&A. So got a lot of, I apologize beforehand, got a lot of information to kind of scroll through. We try to keep these close to 30 minutes, but I know I'm going to go over. Before I jump into SpaceClaim, I want to kind of remind everyone where this sits in the greater process. So at the top of the screen, we sort of have what I think is the most broken down, simplistic 3-step process that every single simulation has, and that is pre-processing, solving, and post-processing. Of course, the solving aspect is going to be most of the computer doing what the computer does well, which is computing, and using all the RAM, memory, and core capability to crunch through all of the math and matrices, okay? But the vast majority of the time that we as humans are working on these models is done in pre-processing and post-processing. In fact, in our consulting jobs, we generally say about 50%, 50, half of the effort of the human to do FEA or CFD is done in pre-processing. So a key component of that pre-processing includes, of course, material properties and the 3D CAD geometry, which is where we're going to be focusing today. And then, of course, discretizing, which we also call meshing, whether it's for structural or fluids. And then, of course, creating those physics, that environment, loads, constraints, and other boundary conditions. And so we're going to be focusing on SpaceClaim and using it in the Ansys Workbench workflow. So basically manipulating geometry, assessing it, measuring it, maybe modifying it, and preparing it for either a structural analysis or a fluid dynamic analysis, so FEA and CFD. So we believe, we won't have a chance to do a poll, but we believe most of the people in the audience are probably going to be using Ansys Workbench. So I've got a screenshot here of 2 different workflows. We've got the static structural workflow, which has, as you can see, the engineering data, geometry, and then the actual FE model setup, solution, and results. And then the newest fluids workflow with Fluent, which has the new Fluent meshing, looks like a 2-component setup down at the bottom, where we've got a geometry component, which we'll use SpaceClaim for, and then we'll connect it to the Fluent with Fluent meshing. And again, this today's webinar is focused on the geometry capabilities in SpaceClaim. Next week, we're going to be doing a deeper dive into preparing for FEA and CFD. And next month, we're going to be specifically focusing on that fluent with fluent meshing workflow. So all these webinars are kind of tied together, sort of our 2020 COVID webinar series. So now, SpaceClaim comes in two flavors. As I just mentioned, SpaceClaim Standalone, which is the standalone program, is going to be used in conjunction with Workbench. So our traditional FEA, Ansys Mechanical and Ansys Fluent and CFX CFD tools. This standalone version has the complete or deep bench, if you will, of geometry tools. So all of the SpaceClaim functionality is available in the SpaceClaim Standalone tool. It's most often used from within or called from within Workbench, and it can be used as the quote-unquote only CAD program. So we have a handful of customers who consider themselves to be analysts, so they're spending the vast majority of their time doing simulation, and so they don't regularly have access to a CAD program, or maybe the company, because they do a lot of R&D or research or scientific laboratory research, maybe they don't have CAD at all. And so SpaceClaim can be the only CAD program. Again, you can start from nothing and build your geometry from scratch. Of course, a lot of it is being imported, and we'll be talking about that a little bit more. The other way to get access to the SpaceClaim functionality from within Ansys is in the new discovery tool. We talked about that last month, so there's a whole webinar on that. But the new discovery tool is really meant for those who are not necessarily working in the traditional mechanical or fluent or CFX, but are either new to simulation or are going to be focused on both design and simulation and back to design and back to simulation. So that discovery product, or that program, which is brand new in July, is a combination of what was used to be called Discovery Live, which is the GPU solver, and what used to be called Ansys AIM, which is the CPU solver, all bundled up with SpaceClaim. So we've got, as you can see, these are just the screenshots of the ribbons. Most of the CAD geometry capabilities are in Discovery. Not all of them. We're going to be talking about a couple of the newer capabilities that are only available in standalone. But as I mentioned in the very beginning, Ansys is investing a lot of development right now in both Discovery and SpaceClaim. We'll see if both tools are going to exist in parallel, or if one's going to be the primary tool or not. We'll see what happens. But for right now, there are two flavors. We're going to be focusing today on the SpaceClaim Standalone. We did a little bit of the Discovery last month. Okay, this is a busy slide, but if I don't know if someone want to take a screenshot of it and just have it for reference, but this is essentially the core capability as a CAD modeler. And again, SpaceClaim, once upon a time, was its own CAD modeler out on the open market, competing with quote unquote the big ones, so Creo and SolidWorks and CATIA, Inventor, Solid Edge, all those tools. So we have a full bench, everything from datum planes and datum coordinate systems and points to our sketching geometry to 3D modeling. The third row down, assembly, so it can handle assemblies if we want to create assembly motion, or if we want to create any constraints, we can do that. It has a full suite of measuring and analysis tools. So of course we can measure point to point, we can do mass properties, we can do some interference analysis. We're going to be doing that a little bit today. And then it actually has a full capability of surface analysis. So if you're looking at surface curvature, so if you deal a lot with consumer products or industrial design parts where the lighting has to reflect it a certain way, or you have to have curvature continuity, if you will, across, for example, panel gaps in a car door. So there's a whole suite of tools here that you can use as well. And then we're going to be digging into the faceted geometry tool. So this is relatively new to me personally. Again, my background is in Creo and SolidWorks. I do a lot of sketching and revolving, and sketching and extruding, and adding material and cutting holes and patterning and things. And so don't have a lot of experience in STL tools. Those of you who are doing a lot of additive manufacturing, 3D printing, are very familiar with STL files. They're faceted, so they're just a bunch of triangles and vertices and edges. And there's a lot of times where we're going to have that geometry that we're starting off with, and for example, scanning something and then putting it into a virtual wind tunnel. So that is a particular workflow that some of our customers have. And so it's important to know how to manipulate those STL files. And again, full bench inside SpaceClaim, we're going to do that today as well. So this is sort of the core capability. I'm going to try to hit 5, what I think are the most important, or at least key capabilities. There's a few more tabs over on the right. You can see, I don't know if you can see my mouse, but towards the right we have repair, prepare, and workbench. Those are specifically for preparing for FEA and CFD analyses, and we'll be doing that next week. Okay, I'm going to jump into SpaceClaim in a second. I'm going to pull up 5 files, and each of the files I'm going to be walking through some of the key capabilities. So the first one, we'll be looking at a pillow block bearing assembly. We're going to be looking at the sort of the assessment, or I'll say analysis, but really just from a CAD analysis. So cross sections and measuring and interferences. So we might get a CAD file, and before we do anything with it, we might want to take some measurements, or figure out where things are in XYZ space, or even look for interferences, prior to meshing. Then we're going to look at a casting, and we're going to be doing a little bit of the fill tool, which doesn't exactly fill things in the way you might think, in conjunction with the selection tool. And so the 1-2 punch of selecting certain geometry and then filling it is really key to quick and easy workflows in manipulating CAD and preparing for FEA and CFD. Then we're going to get into driven dimensions, which a lot of our customers don't know that SpaceClaim can do. They think SpaceClaim is just, oh, I grab a surface and I pull it, and then I can't control how much I pull it, or I can't move a hole an exact amount. You absolutely can. You can also move it an exact amount and then parameterize that to, for example, do a virtual suite, if you will. So a DOE. I want to look at various hole patterns or wall thicknesses or materials, and I want to sweep that through my FEA tool. We do that a lot. So we're going to show how to create driven dimensions, how to use the ruler and create parameters. Then we're going to talk about the latest capability in SpaceClaim, which came out in July, which is sketching constraints and block recording, number 4. New to SpaceClaim as of right now, so just in the last month or two, is the ability to establish constraints while you sketch. Now, I know what you're thinking. I've been in SolidWorks for 15 years. I've been in Creo for 20 years. We've been sketching with constraints for that long. Yes, you have. But Ansys's tool for SpaceClaim has not. It came out as a direct modeler, and it's pretty obvious that Ansys is investing a lot of development into the tool to include both the direct modeling capability as well as the traditional sketch constraint that a lot of us are used to. And now, in addition to sketching constraints, we have a model tree. So we have a history. For the first time ever in SpaceClaim, we have a history. And so we're going to talk about that, and then we're going to jump into a quick demo on STL files and how do we manipulate and modify some of that faceted geometry. Okay. I'm going to slide over to SpaceClaim. So this again is SpaceClaim Standalone. I've got multiple models open. I've got my casting. I've got our spring plunger. I've got our sketching blocks, which is just a surface, and I've got our scan shroud, which is an STL file. So I'm going to open up the pillow block, and so I'm just going to hit my file open, and I just want to show everyone that SpaceClaim does have the ability to import any single CAD file. You don't need to have an additional license or anything. If you're getting CAD straight from CATIA, or straight from an old Ansys database, or straight from Creo, from Siemens NX, from SketchUp even, Solid Edge, SolidWorks. So any of those native CAD files can be opened directly in SpaceClaim, which is really nice. So I'm just going to click on all supported files, and you'll see that today we're going to be working with a combination of a step file. I'm going to open that up first. The other ones I have already opened. These 3 are already saved in the in the SpaceClaim document SC.doc file, and then we are going to be looking at that STL file. So let's open up the step file. I'm going to do a quick import down here at the bottom. I'm just going to slide it over so I have these in order: 1, 2, 3, 4, 5. So this is an assembly for a bearing. It's got a little grease fitting on it, and the first thing I want to show is some of the introductory tools for just measuring and analyzing kind of what do we have here. So the first thing I would do for an assembly is look at a cross section, and so I can either go into design and there's a cross section mode, or I can hit the X keyboard, and I kind of like using some of the keyboard shortcuts. So my X keyboard for cross section, use my cross section tool. I can snap to a surface, and then right down here I can start to move that. So again, I have like this coordinate system that I can use to modify and move, and as soon as I move it, I'm in place. Everything looks good. One of the things that is interesting and unique with the SpaceClaim workflow is, although our features are across the top, we have all of our options. They kind of pop up in this upper left-hand corner. So no matter what we're doing up here, if you're new to SpaceClaim and you're a little bit disoriented because it's got a slightly different interface than Creo or SolidWorks, just keep an eye on this location right here. These are all of our options. And then there's some descriptive text right here. So it's saying, hey, double click to select the chain of loop, triple click. Okay, that's fine. I'm going to click on this option, which is up to. And what that means is I'm going to move this cross section specifically up to a certain point. And I can actually snap to, there is it's kind of hard to see, but there is a little axis right through the middle of that. And by doing that, and I'm going to look at this in 2D, by doing that, I'm actually splitting, this part right in the middle, and I can see, do I have any interferences? Do I have, what do I have for parts? Where are my assembly parts located? And it can kind of correspond to where everything is related to our structure tree over here. So shortcut to the cross-section tool, very important for looking at assembly. The larger the assembly is, the more complex it gets. I can get back to my 3D mode using this icon here, or by just hitting the D. So X and D, those are toggling back and forth. Pretty simple, easy start. Let's jump into the measure tool. So over here on the measure tab, I'm going to click on the measure tool, and I have the ability again to just do point-to-point measuring. This is pretty standard for any control gets me anything for multiple sections. That's all fine and dandy. But one of the things that sometimes we need to know is, where is something in the XYZ space? And an example might be, I'm doing a structural analysis and I want to put a point mass out in space to represent a subassembly, and then I want to use, like a CRIG or an RBE3 command, some sort of command to connect that point mass back to my model. So a lot of times the step file might have a coordinate system that is in a really weird location, or a location that doesn't make any sense. I'm just going to make a new coordinate system in some random location. So by the way, if I were to just to click anything in here, down at the bottom, I do get sort of the default XYZ location for the coordinate system. If I click an edge, for example, I get sort of the length. So there's pretty quick and easy ways just to get a general idea of how big things are. But let's say, for example, I want to create a new coordinate system. I'm going to drop it down into the corner right here, snap to that vertex. And then I'm going to go back to my measure tool. And one of the options for the measure tool is to use a coordinate system as a reference. And so I can grab that and say, I can either select it from here, I can select it down here. As soon as I do that, I'm now sort of dynamically hovering over the model, and I get my XYZ location. And that's actually really, really helpful. For example, where is this in the Y location? How far back is that grease fitting? And it looks like in the Y location, it's 17.272. And so, in fact, it's not even in the middle. But that's a really easy way to get a good idea of where is everything in the XYZ space. And again, that's just using the option that's up in the upper left-hand corner for referencing a certain origin that we create. So again, we can create multiple origins, multiple coordinate systems, and find out where everything is relative to that. So the other thing we obviously want to look at for assemblies before we get into meshing is we want to understand if we have any interferences. There's a couple different ways to do that. The one I'm going to show you today is going to be into under our measure, we've got interference volumes. And so I'm just going to click two parts, and I'm going to get, this is a typical sort of CAD program. I'm getting my interference volume. I'm getting some information here, and I can do a few things if I want to get rid of that. From this tool, actually, you can create a separate volume from that. So if I just click on that and click on the interference, I actually just added that. That's not the most helpful, not probably a typical workflow. More typical workflow is, how do I remove that interference? And so what I'm going to do is go back into cross-section mode, grab this. I'm going to move it back just a few. So it looks like we're already in the middle. Fantastic. Go to 2D, go into my measure, go to volumes. Actually go into my prepare tool. So under prepare, and again, Terry's going to dig into all these options next week. There is another interference tool, which is a little bit more for those of us who want to get rid of the interferences. So this automatically shows us what those interferences are, and we can come right over this interference and click it. And as soon as we click it, what it does is it uses the smaller body to do a Boolean operation on the larger body. If you want it the other way around, you'll have to wait till next week. Little plug there. There's a couple different ways to do that, but in the interference tool, it's pretty simple. Do interference, click on the interfering volume, and the small one is going to be used to cut away from the large one. Another way to do that is, let's say, for example, I wanted to use the pull tool. So I'm just going to hit escape and come all the way back out. So now I'm looking at my assembly from cross-section again, and I might want to go into design and I want to pull it. And again, if I just grab that surface, and again, this is in 3D, you can see I've got that sort of surface on the outside of the bearing. And as soon as I click on it, I can move it dynamically. Now I want to make sure I move it exactly even with the inner race surface that's on the pillow block. So again, my options, I can come all the way down here. This is my up to, and I'm going to move it up to, and I'm just going to hover over the surface that's on the actual pillow block itself. It should be right there. And I can escape out of that tool, go back to 2D, zoom in, and you can see I've now just moved it exactly up to that location. So combination of the interference assessment tool or interference analysis, combination of the cross section, and a combination of the pull tools here will allow us to fix any of the interferences. Okay, that is the first model for the pillow block. If you have any questions, just take a quick note and we'll do some Q&A at the end. The next one I want to show is the casting. So this casting, we're going to be looking at the fill tool, which as I was learning this, I've been learning this over the past 9 to 12 months or so. I've been playing with SpaceClaim a lot. And I didn't quite understand what fill meant. I come from, again, sketch, extrude, sketch, revolve, sweep, loft, those are the words that I'm used to, not pull, move, and fill. And pull and move are relatively straightforward. I grab something, I pull it. I grab something, I move it. Fill is a little bit counterintuitive in my mind. Fill is actually a tool that's used to remove things. I'm not quite sure, really creative name there, but what it's actually doing is it's removing things that you select and then filling it back in a certain way. And the power of the fill tool is exactly how it fills in the geometry after it gets removed. And what I'm going to show you is just a couple of simple ones. For example, if I wanted to fill this radius, I just grab it from the fill tool and I hit the green check mark. So what it does is it removes that surface and fills it in by projecting the two sides forward until they meet. I'll hit Control Z for undo. If, for example, I wanted to remove a hole, again, in the fill tool, I just grab the hole and I remove it, and it's filling it back in based on the surfaces that are around it. Let's go one step further, okay? I have a radius up here. If I wanted to remove this radius, and again, it's a common thing that we're going to do for preparing for FEA if it's not a critical radius, so I would grab that radius and I would hit the green check mark. And the problem there, of course, is it just removed that surface and filled it in with the adjacent surfaces, which is just taking these two planar surfaces and extending them until they create an edge. And that's not usually what we want. As a CAD modeler, I can look at this and probably assess that this round across the top was probably the last round that was put on the rib feature. And I can tell that the way that these rounds are intersecting here. And one of the cool things with the fill tool is it's powerful when you use it in conjunction with the select tool. So there's a couple of unique things about selecting. If I select this surface once, I get just the surface, okay? If I double click on it, I get the whole edge of surfaces, or the whole stream of surfaces from this corner all the way down to that. So all the adjacent surfaces here in the round. And so in the fill tool, if I remove that, of course, that is basically undoing the radius that was added in CAD previously, right? If I select one, double click, and I get a whole series of surfaces that were tangent to that one. So this got extended to this, which got extended to this, which got extended to this, right? So it really does depend on the first one that you select, how far it goes. And then the triple click, 1, 2, 3, gets me the whole body. And so it's not very helpful to be selecting the whole body when I have just one body, but you can imagine in an assembly or something, you could say select an entire thing and then start, grab this 1, 2, 3, and then start moving it around with the move command. Okay, So let's say I'm preparing and I accidentally just do this, and then I start doing some more things, and all of a sudden I go back and say, oh shoot, I want to add that radius back, and I don't want to undo all the other things I've done in the meantime. Another sort of not so intuitive function, but it's really, really cool, is how to add a round or radius. And the really easy way to do that is basically to take an edge and just pull it. And again, I don't want to just pull this. If I try to pull that, I'm going to get a round on just that edge. I can undo. So 1, 2, pull. So all of the tools that we're used to in a traditional CAD tool are here in SpaceClaim. It's just that workflow and that button click is just a little bit different. So that's one of the things I just wanted to show you guys today. I can also type in the number 1 and go from there. So that brings our round back. That's a little bit on the fill tool and the selection tool. And I want to do one more. So one of the things that we'll do, for example, on a casting, we'll cast in serial numbers and brand names and whatnot. And so when we're doing FEA, a lot of times the depth of these is quite small, right? So this right here is 0.5 millimeter in some cases. And so it's not going to affect, in many cases, the stress profile of the part, or it's not going to affect the factor of safety. So what I might want to do is I might want to remove that. Now, if the CAD modeler was really good, no comment on where the CAD model came from here, but they would have rounds, and if everything was rounded and tangent, then I could double click this just like I did before and get this whole piece. Well, as you can see here, this is really projected text. And if I just double click this, I'm not even getting the adjacent surfaces. So there isn't even a tangency there. And that can get kind of a pain in the butt. I'm not going to sit here with my control key down. I could, but I'll accidentally grab an edge or a vertex, and I know we've all been there before. And so again, the power that is in SpaceClaim has a lot to do with the selection tool. And so I'm going to go into my selection tool and hit using lasso. And by using the lasso, I can just go right around those surfaces and grab them all. And you can see that I just kind of tilted the model so it was kind of in a space where no other surfaces were behind it. And I just grabbed the lasso there, and I can go into my fill tool, and it's gone. That fast. So the power in here is not just the fill tool, but the ability to isolate the selections I want. So lasso, I come around this text, I make sure I grab it all and nothing else, and I fill it in, and it's really fast. So sometimes it's a little bit more about how you select things than it is about what you do with those selections. So there's a couple of tips and tricks, so to speak, on the fill tool and the selection tool. And again, there's even more options in here on how you want to select things, polygon, painting, things like that. So that's the casting. That's number 2. Number 3, this is the good stuff. This is what really started to blow my mind in SpaceClaim, because again, I'm used to sketching and extruding and then going back and looking at my model tree and saying, oh, where's that dimension? I can go modify that real quick. Well, this most likely started off as an IGES file or a step file, or maybe it came from SolidWorks or Solid Edge or something. And so I don't have access to those original dimensions. I don't have access to what we call the design intent. I may not even have the ability to call the designer. I'm just left with this CAD model, and I have to do something with it. So what I'm going to do is I'm going to play around with this hole a little bit. Let's say, for example, we wanted to change the diameter, right? So I'll just grab that, and I'll just pull it back and forth. And you can see I've got some numbers on the screen that are going to update. And if I wanted to get something really, really exact, I could say, oh, I want this to be exactly 1. So in the middle of pulling it, when I have this dimension up, I can just type in 1, and it snaps. Now, what I can also do is just to the right of that, there is our parameter button. That parameter button is what ties this value back to the Ansys environment. So as soon as I click that, it goes from blue to gray. Down here, I get this group 1 created. So over here in our structure tree, there's a tab, a window for grouping. This is where we have our name selections, which Terry's going to talk about next week in more detail, and our parameters. So because I was in the middle of this pull feature, and I clicked that parameter, I now created that parameter here. And I'm going to rename this and say hole diameter. This hole diameter parameter is now available to me wherever this goes. I have this, believe it or not, available in Workbench, right? So I now have it available in my FEA mechanical tool. I have it available in my CFX and my Fluent CFD tools. And I can always, no matter what happens in here, it's this model, I'm always going to be able to go back to here, go to my ruler dimension, and change this to a certain value from 1 to 1.5. Now, that's pretty straightforward and easy. That's just a diameter. What if I wanted to control the location of this hole with a parameter? And again, however this was modeled, that information is lost. So I might want to move this hole. So I'll grab the hole, and I've got my coordinate system. And as soon as I select a direction, so I selected the green direction here that's along the x-axis, I get a little pop-up window, and I have a ruler. So I'm going to grab that ruler, and I'm going to come right over this surface, 3.455, and I'm going to click the parameter. What I just did was establish that dimension as a driving dimension, okay? That dimension will never go away. I can come in here and say this is 3. I can come in here and say this is 1. And now I have complete control over the location of that hole, and that can go downstream again into my FEA or CFD tool. These are really, really powerful. This was kind of in my mind getting blown phase of learning SpaceClaim, because I always thought that, you know, I would just have to go in here and start moving and modifying stuff, and I could never, you know, I could never control it. So this is, in my mind, a huge step forward in using a direct modeling tool for parametric CAD modeling. Now, let's go one more level. So back over in the structure tree, there's a plane, and this plane has some dimensions on it, and those are created from the detail tab up here. So there's a full kind of a drafting set of tools. Again, this used to be a standalone and is a standalone CAD tool, so creating drafting drawings and whatnot. So we can create notes and dimensions, and we can create any dimension and plaster it right on that plane and have it. And when we go back into our design and we go to move something, and let's say, for example, I wanted to, I want to pull this. As soon as I grab that, I now have little stars next to these guys, and I can start to control which dimension is modified as I do that. So I grab that 15 and say, I want to make that 17. And that's going to update and hold all of the others that have been created sort of, you know, constant for the time being. Again, I can go in and I can start to parameterize these, and I now am able to manipulate and modify a quote unquote dumb STP file or set file or dumb IGES, right? I previously had no parameters, and I can start to build in the parameters and the design intent, even if I had no idea where it was. So really, really cool stuff in SpaceClaim to start to reverse engineer not just the geometry, but also the design intent. So that is examples of creating driving dimensions, of creating parameters that can be used in subsequent analysis, and modifying the different ways that we want to control how this thing updates as we update it. Okay. Now we're getting into the really, really cool new stuff. So this is sketching, and I'll call this the new sketching, if you will. So the first thing that we're going to show is this is an existing sketch, and I've got in my structure tree nothing but a surface. So at one point in time, somebody in this model sketched a circle and sketched a rectangle and some other lines and whatnot, and just kind of ballparked it. Hopefully it's symmetrical, hopefully it's not, or whatever they wanted, whatever design intent they need. But we have no control over that. I can't go back. I can't edit that in its original form. I can only use my editing tools here, pull, move, and fill, okay? That was previously. Now, when I go into my sketch tool, let's say, for example, I want to add some more sketches to this, okay? So I'm gonna, let's say I add a rectangle onto this surface. I'm just gonna look at it in 2D. Let's say I wanted to add a rectangle down here at the bottom. As I am creating this sketch now, this is how it used to work. I had my 17, my 25, I create my sketch. Let's just drop it right here. Now, brand new in 2020 R2 is I have constraints. Now, again, chances are you're listening to this or watching this, you come from Creo or SolidWorks or Solid Edge or CATIA, and you're like, this has been around for many moons, and it has been around for many moons, but not in conjunction with the direct modeling in SpaceClaim. Very, very, very familiar will be the fact that we've got colors. The colors represent things that are constrained and under constrained. We can over constrain it just like we can in other tools. In this case, what I'm going to do is I'm going to grab just a line here, and I'm going to add that there. And we're going to make that vertical, and we're going to use the equal. Get that equal. I want to make it equal to this. It's over constrained, right? So over constraining based on where other constraints have been created. And if I turn on my constraints, I can see that I might have some constraints that need to get removed. There we go. And I can add my constraints. So very, very comfortable. This should feel relative to what you're used to in another CAD program, which is I'm sketching. I've got constraints that I can manage on the fly. I can create, fully constrained sketches and whatnot. Now, if I were to hit the end sketching, there we go. I created my surface. In that workflow, we still don't have the ability to go back and edit any of the things that we did. We have to just keep driving forward with our pull, move, and fill tool. So one step forward for sketching, for those of us who come from our sketch tool, I have constraints. Great, sketching is going to start to feel a little bit more comfortable. Now, let's also talk about the history. So this used to be a beta in previous versions, but it's now released for the 2020 R2, which is what's called block recording. And block recording is really just moving my controls for the webinar. Block recording is really just a history, very, very similar to the model tree and the history that we're used to. Although this is relatively brand new here in SpaceClaim. So let's say I go into my sketch. I want to create another sketch on this surface, and I'm going to put, let's say I put a rectangle up here. I'm going to put a circle in the middle of it. Oh, it's not in the middle. Let me just slide that over, slide it over. I'm going to put a circle kind of right here, and I want to put it in the middle, so I'll just use construction lines to do that. Snap, 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 and snap. So now if I just add a dimension to this, we're okay. Add a dimension to this, we're at 18, and we add a dimension to this, we're at 24. So now you can see I've got all the dark blue sketches. I've got a fully constrained sketch. I've got a combination of constraints and dimensions. And as soon as I hit end sketch, because I had block recording turned on, I now have the history of that sketch. So again, the left-hand side, traditional SpaceClaim, all I have here is a list of my geometry, surfaces and curves, bodies, assemblies, whatnot. On the right-hand side, with my block recording turned on, I now have not only a dimension sketch, but I have a history, and I can go back into that sketch. It rolls me back. I can take a look at all the stuff I did. So for those coming from a traditional or a different sketch-based CAD tool, this workflow is going to start to feel a lot more comfortable. And maybe you've been fretting getting into SpaceClaim because it's a different workflow. Well, now this workflow is very, very similar to what you're used to in in SolidWorks or Creo or Inventor or whatnot. So again, we can come out of that sketch. Those are always going to be there, and this is going to continue to build from top to bottom like it does in a traditional model tree that we're used to. Additionally, inside here, we have that lovely P again. So we can parameterize, once again, any of the dimensions that we type into our sketch. We parameterize that, and we can basically use that in subsequent analyses or calculations. So let's say, let me just take a peek real quick, which is which. So 10, dim 0, that's our circle, and then dim 1, that's the height, and dim 2. So dim 1 and dim 2, those are my rectangle dimensions, and dim 0 is my circle. So let's say, for example, I wanted to parameterize dim 2. I just click on the P, and I've got my B1 dimension P1, and that's 24. And if I wanted to, for example, here, I can actually go to my dim 1 and basically assign it the same value. And so now these are the same value. I get a little bit of an update. This is a, hey, we need to regenerate, and then we just basically regenerate or play, if you will, this script. So again, this is a scripting. It's in Python, so it's Python scripting sort of overlaid onto the SpaceClaim model, kind of tracking and keeping track of everything you do. Again, I go back into my sketch, everything's there. I've updated, everything is, these two are matching 24 again because they're being driven by the same dimension. And the circle's still 10. And I can come down here at any point in time and I can change this to, back to 18. And this is my update, and I hit play. Now, this is a little bit, I'll just be honest, it's a lot of button clicks. compared to what you're probably used to. The regeneration is not automatic. We have to manually do it, but it's a huge step in getting SpaceClaim to do modeling any way you want. So whether you want to do it in direct modeling, whether you want to do it in sketch-based with parameters and dimensions and a history, it can do both. So those are the things I wanted to show that are brand new in 2020 for sketching constraints, and for block recording, which is sort of the model tree, if you will. Okay, last one. This is the STL file. So this is a file that could have come from, for example, it looks like a shroud for a hand tool or some sort of, I don't know if it's a saw or some other device. But this is a plastic shroud, and it was scanned. I'm assuming it was scanned at some point, and then it was faceted, or it could have just been faceted from a CAD tool. But the bottom line is we don't have what we call B-rep. We don't have curves and edges and surfaces and volumes in that traditional sort of geometry hierarchy that we're used to. Instead, we have facets. We have triangles and triangles and more triangles. And these triangles can be very, very small and very, very high aspect ratios, really narrow little corners and edges. And traditionally, a lot of the CAD tools, you open this STL file up and you have very, very limited capability. But for a long, long time, SpaceClaim's had a full suite of modifying this geometry. And so everything that we're used to from the design tab, which is pull, move, and fill, we can do all of that with facets as if it were sort of a more traditional B-rep geometry. So let's say, for example, I wanted to modify this standoff. So again, I would select one to grab that surface. I would double click to grab that whole surface. And that's basically grabbing all of the surfaces that are very, very close, if not exactly in plane with each other. I'm going to go to design and I'm going to go to pull. And I immediately have the ability to start modifying that. And you can see, in addition to being able to modify it dynamically, I also have a number, call it 1. And as soon as I type in that number from the keyboard, I get my parameter. So now what we're doing, and again, we're creating that group. This is going to be boss height. What we're doing here is starting with completely dumb, if you will, geometry. I have facets and triangles, and I'm starting to build back in some of the design intent that was originally there from whoever designed it way back when. So really, really cool stuff in regards to adding some intelligence to a CAD file that may not have had intelligence from before. Again, I can grab this, double click, go to pull, and now I have the ability to change that diameter. And you can see the triangles. Let me zoom in here. You can see all it really does is move the vertices and those facets, and it's just kind of updating the triangles on top. They're kind of like long and skinny and then short and fat. So really a neat way of doing that. Another thing I can do, and again, this is in conjunction with the selection tool. If I wanted to box select, and I wanted to, let's say this boss, I wanted to move down here. And again, I could box select this. If I box select that by default, what I'm doing is I'm grabbing, I have that option turned on. I'm grabbing everything there. You're probably thinking, how did it know what to grab? Let's talk about this. Down here, I have a through. So if I change box selection to automatic and I grab that, I'm only grabbing sort of what is in the box. I'm going from left to right. So it's grabbing anything that is in that box. If I go right to left, it's grabbing anything that's touching the box. If I want to grab just these surfaces or facets related to this boss and not anything in the background like that, what I do is, or missing, for example, the back side, what I do is I change this selection to through, kind of position this sort of in a way that I want. I grab left to right. So now it's only going to select triangles that completely exist inside that box. I'm not grabbing anything else. I can look, I've got all sides of that box. I'm in my move tool, and now I can just take that boss and I can move it to another location. This is really, really, really powerful because now you don't have to spend all the time to completely rebuild this with parametric geometry or cut this off and add a boss or anything like that. You can just come right in here and you can move it. And as you can imagine, because I can move it, I have my ruler. I can type in a value to, I can parameterize that, I can do everything that I wanted. So all the tools here in SpaceClaim to reverse engineer and build some intelligence into the model, no matter where the CAD came from. So really, really cool stuff. Not your not your grandparents' CAD tool, that's for sure. So to recap, excuse me. Okay. To recap, these 5 models we put together for this demo to kind of show what I think are pretty important tools that may change the way you look at SpaceClaim, may not, may motivate you to open up the tool and take a peek at it. We looked at cross sections and measuring interferences. We looked at the power of using the selection and the fill tool to remove complex geometry in the way that we wanted. We looked at adding driving dimensions and using the ruler to basically rebuild the design intent that was there originally at some point, even if it's a step file or a generic file, creating parameters so that we can use that downstream in FEA and CFD. Brand new sketching constraints and block recording, which is starting to make SpaceClaim look and feel like the CAD tool that we may use on a daily basis in conjunction with Ansys. And then, of course, modifying STL File. So some people use a lot of STL files, some don't, but just know that if you do, maybe you're paying for too much software and you've got another tool that you don't need, because SpaceClaim has the ability to modify those. Next steps. Okay, if you don't have Ansys SpaceClaim, just let us know. We can get you in there for 30 days. Take a peek at it, both flavors. If you're new to simulation, new to Ansys, new to SpaceClaim, we would probably put you in that discovery tool just to give you an idea of what it can look and feel like. Pretty easy learning curve. Take a look at the webinar from last month if you want to see what that tool looks like. If you're in Workbench already, or you're in mechanical or CFX or Fluent, and you want to get a peek at SpaceClaim Standalone, just let us know. We can get you that demo. If you are already a customer and you're not sure if you have it or not, just shoot us an email. We can take a look at the license file and see if it's in the latest license file or not. A lot of the tools like Fluent and CFX, depending on what level you have, and same with mechanical, the higher level software actually comes automatically with SpaceClaim. So you may have it and you don't know it. And if you do have it and it was on the install, take a look in the start menu and open it up, or launch it from Workbench. And also take a look at the Learning Hub. So a lot of the files I use today, those are demo files that came out of the Learning Hub that I've been kind of playing around with quite a bit as I learn this new CAD tool. If you don't have access to Learning Hub, just let us know. We can get you a quick take a peek at it. And then there are for very, very, very affordable pricing, you can get access for a year or something like that. But if you want to take a peek at it for a couple months, let us know. We can get you in there and take a peek. There are hundreds and hundreds and hundreds of videos. Everything that I went through today, there's a video that's at least 10 minutes, 15, 20 minutes long on that capability, and it digs very, very, very deep. Just shoot us an email. So with that, thank you very much for hanging on tight. A little bit longer than normal, right at 40-ish minutes, maybe closer to 50. I thank you for your patience. This is the first of 2 SpaceClaim webinars. We're going to be doing the second one next week. We're going to be digging in deep on a lot of the preparation for FEA and CFD. And Terry's going to be doing an awesome job on that. And then the following month, in October, we'll be doing Ansys Fluent meshing. So with that, I will open the floor to any Q&A that everyone has. I'll leave it on this slide right here. So any questions from anyone? I know a lot of information. Thank you so much for your patience. Nothing in the chat, no questions on pulling in multiple CAD files or selections or fill tools. Is there anything that I went too fast on? Driving dimensions, parameters, sketching constraints. Comprehensive. Awesome, awesome, awesome. Okay, maybe it's time for another coffee for some people. I will let you go. Once again, this is the first of 2 SpaceClaim webinars. The next one is next week. If you want to see any of the videos that we've done, they're all on our YouTube page, and we will talk to you soon. Thank you so much, everybody. Take care. Stay safe.